Our topic for today is simultaneous equation, one linear, one quadratic. When a pair of simultaneous equations contains one linear, one quadratic, for example, solve 2x minus y equals 10, equation 1, and 3x plus y squared equals 22, equation 2. Begin with the linear equation, that is 2x minus y equals 10, equation 1, and make one of the unknown subject of the equation either x or y. I choose y. That's why y equals 2x minus 10. Substitute the result into the quadratic equation to reduce the unknowns to 1. What's the quadratic equation? 3x plus y squared equals 22. Now we are substituting this value of y. That will give us 3x plus open bracket 2x minus 10 close the bracket all squared equals 22. And when you expand that, you are going to have 4x squared minus 37x plus 78 equals 0, our new quadratic equation. Now solve the new quadratic equation by either factorization, formula, or completing the square method. Let's use factorization method. First thing, you must know the product of the roots, which is the first term times the last term. That gave us 312x squared. Then the sum of the roots, which is the middle term. Now what you are going to do is think of two numbers that when you multiply them you have the product of the roots, and when you add them or subtract, you have the sum of the roots. That is what I did there. I used minus 24x and minus 13x. Then you substitute them for the middle term and find the value of x. Having gotten the values of x, you have to substitute them one by one. For example, when x equals 6, what will be y? Substitute it into equation 3. That gave y to be 2. And when x equals 13 over 4, what is y? And when you substitute, you have y to be minus 7 over 2. Hence, when x equals 6, y equals 2. And when x equals 13 over 4, y equals minus 7 over 2. That is the final solution.